Welcome to the DIY Honda Garage channel. The diagnosis of DTC P0641, which stands for Sensor Reference Voltage A malfunction, indicates a potential issue within the sensor reference voltage supply circuit, affecting several sensors in the Honda Pilot from 2016 to 2022. This malfunction can impact key components that send critical data to the Powertrain Control Module, PCM, affecting overall vehicle performance and efficiency. The PCM uses this voltage to determine the operational status of various sensors and components, such as the manifold absolute pressure MAP sensor, the EGR exhaust gas recirculation valve, and the fuel rail pressure sensor. Failure to address this issue can lead to further complications in the vehicle's operation, including reduced fuel efficiency and increased emissions. It's essential to start with a careful verification of the problem and thoroughly follow troubleshooting steps to identify the root cause effectively. The process involves utilizing the Honda Diagnostic System, HDS, to clear the DTC and check for any pending issues, ensuring that all connections are secure throughout the diagnostic approach. DTC P0641 signifies a malfunction in the sensor reference voltage A, primarily impacting the diagnostic performance of several critical components in the Honda Pilot. Some of these components include the MAP sensor, which monitors the intake manifold pressure to ensure optimal fuel-air mixture, the EGR valve, responsible for recirculating exhaust gases to reduce emissions, the fuel rail pressure sensor, which monitors the pressure in the fuel rail, and the accelerator pedal position APP sensor, which detects the position of the accelerator pedal. The output shaft speed sensor is also affected, particularly in 6-speed automatic transmissions, which measures the rotation of the transmission's output shaft. Other sensors like the brake booster pressure sensor and the fuel tank pressure FTP sensor play crucial roles as well. These sensors are strategically located near their respective systems. For example, the MAP sensor is often found in the intake manifold area, making it easier to access for diagnostics or replacements. The possible causes for DTC P0641 center around poor electrical connections, faulty sensors, and a malfunctioning Powertrain Control Module, PCM. Poor connections can occur due to corrosion, loose wires, or damaged terminals, which can impede the proper flow of voltage to the sensors. Similarly, a specific faulty sensor among those listed, like the MAP or APP sensor, can disrupt the voltage supply that the PCM needs to manage engine performance. Any degradation in the component's integrity will manifest as an inability to read accurate data, leading to erratic behavior of the vehicle. Moreover, if the PCM itself is compromised, it may fail to process the reference voltage signals correctly. Given the interconnectivity of these components, a thorough diagnostic approach is essential to isolate the root issue effectively. Symptoms stemming from DTC P0641 can severely affect the driving experience in the Honda Pilot. Drivers may notice reduced engine performance, manifesting as sluggish acceleration or difficulty reaching higher speeds. This can be particularly noticeable during demanding driving conditions, such as merging onto highways or going uphill. Additionally, increased emissions may accompany the malfunction because misreading sensors can lead to improper fuel-air ratios, negatively impacting the vehicle's environmental footprint. Dashboard warning lights specific to the diagnostics of the engine and emission systems may also illuminate, alerting the driver of an underlying issue that requires attention. Addressing these symptoms promptly through diligent troubleshooting can help mitigate long-term damage and performance degradation. In the first step of troubleshooting for DTC P0641, begin by turning the vehicle to the on mode without starting the engine. This action will power the onboard systems, and enable diagnostic tools to interface with the vehicle. Utilize the Honda Diagnostic System, HDS, to clear any existing DTCs. This step resets the diagnostic system and allows you to assess whether the problem persists. After clearing the DTC, it is crucial to check again for any pending or confirmed DTCs. The presence of DTC P0641 following this action indicates that the failure has been duplicated, pointing to a persistent issue, while its absence may suggest an intermittent failure. Intermittent failures may relate to weak connections, necessitating further investigation to ensure robust electrical connectivity in the affected components. Step 2 involves determining the possible failure area related to the sensor reference voltage circuit by isolating each component. Begin by turning the vehicle off and then disconnect the connectors of relevant sensors, which include the MAP sensor, EGR valve, fuel rail pressure sensor, APP sensor, output shaft speed sensor, brake booster pressure sensor, and FTP sensor. After all connectors have been safely disconnected, turn the vehicle back to the on mode to restore power. Utilize the HDS once again to clear the DTC and proceed to check for any pending or confirmed DTCs. If DTC P0641 is present again, it confirms a fault related to one of these isolated components. Conversely, if the DTC does not appear, the issue may lie in poor connection or loose terminals, which require further investigation, illustrating how isolating components can help clarify where the problem lies. In the third step, the focus shifts to checking for shorted parts. Begin by systematically reconnecting the previously disconnected sensors one at a time. After reconnecting each component, it is essential to check for pending or confirmed DTCs using the HDS immediately. If DTC P0641 reappears after reconnecting a specific sensor, that sensor likely caused the malfunctioning condition and requires replacement. On the other hand, if DTC P0641 does not reoccur after reconnecting a sensor, it suggests that the issue may stem from poor electrical connections or terminals related to the sensor, necessitating a more thorough examination of both the sensor and its connections to the PCM. This organized approach ensures that each component's functionality is verified and helps narrow down the source of the DTC, directing you effectively towards resolution. Step 4 involves a critical check of the circuitry, focusing on the voltage supply lines, VCC lines. Begin by placing the vehicle in the off-lock mode and then jump the SCS, service check signal line, with the HDS, waiting for more than 1 minute. Disconnect the PCM connectors A and C, both having 51 pins each. Next, you'll need to verify continuity between specific test points and the body ground, ensuring the vehicle remains off. The test conditions require disconnecting the sensors and PCM connectors to accurately gauge the voltage pathways. Use a multimeter to determine continuity between terminal numbers 19 and 41 on PCM connector A, or terminal 32 on PCM connector C directly to ground. If continuity is present, a short circuit in the VCC wire needs to be repaired. If continuity is absent, the VCC wires are in acceptable condition, prompting further investigation into authorized service information or the potential need for a replacement PCM to resolve the issue effectively. Final repair verification is crucial for ensuring that all identified issues have been effectively resolved. Begin by ensuring that DTCs have been cleared using the HDS and confirm that there are no returning error codes. Following this, a test drive of the Honda Pilot should be conducted to assess the vehicle's performance under normal driving conditions. During the drive, closely monitor the functionality of all relevant sensors, such as the MAP sensor and APP sensor, to ensure they are operating correctly without triggering any warnings or symptoms related to the original DTC. Pay special attention to engine performance, responsiveness, and fuel efficiency, validating that all systems now function harmoniously. Ultimately, this verification process affirms that the repair was successful and guarantees that the vehicle is ready for further use without the previous DTC concerns re-emerging. Preemptive maintenance is essential in preventing issues like DTC P0641 in the future. Start with regular inspections of all electrical connectors and wiring at risk of wear or corrosion. Periodic cleaning and secure reconnections can significantly mitigate connectivity issues. Additionally, utilizing high-quality replacement components will enhance durability and reliability, ensuring that sensors perform optimally. Monitoring the overall performance of the vehicle system through routine checks can help identify small issues before they become major problems, allowing for timely repairs. Finally, maintaining a detailed log of any repairs or replacements can assist in diagnosing future issues that might arise, contributing overall to the longevity and efficiency of your Honda Pilot. In conclusion, efficiently addressing DTC P0641, which relates to sensor reference voltage A malfunction, requires methodical troubleshooting steps designed to isolate the root cause of the problems effectively. By first verifying the issue with the Honda diagnostic system, you are positioned to understand the broader implications of this DTC on vehicle performance. Each component's integrity must be examined individually, ensuring all connections are robust and free from corrosion or looseness. Implementing preventive maintenance practices will be invaluable in averting similar issues in the future. Consistent checks and the usage of high-quality parts will contribute to smoothly running systems and enhanced vehicle reliability. By following systematic diagnostic paths and performing post-repair verifications, you ensure both immediate solutions and long-term functionality for your Honda Pilot. Please like and subscribe to the channel. See you next time.